Hello everyone, I am Aditya Tripathi and I'm going to talk about sketch carried object localization. This is a joint work with my colleagues Rajat, Anand and Anirban. Given this natural image, can we localize the cake in the image? We can use a faster RCNN, however, it works for a fixed number of categories and it does not scale well for unseen categories. For example, you may have a case in which the cake category was not seen in the training. The solution to the problem is to use query guided object localization. We can use a natural image as a query or a text, but there are many cases in which both the natural image or the text queries are unavailable. It may be because of copyright laws, privacy issues, or the data collection and annotation overhead of novel classes. In this work, we propose a novel task of sketch carried object localization, in which, given a natural image, can we localize an object on it just by drawing a freehand sketch of the same. In this example, it is the cake that we want to localize. Vanilla faster RCNN can be modified to allow query-guided object localization. After the region of interest proposals are generated, these are scored with the sketch query to generate localizations. But is it enough to solve the problem? No, because vanilla RPN does not use the query information for generating region proposals, and therefore it may not generate proposals relevant to the object of interest. We propose query-guided region proposal network, which utilizes cross-modal attention to incorporate query information in the RPN. Cross-modal attention learns the spatial compatibility between global sketch features and local image features, which can be seen as an attention. And then these attended feature maps are passed through a region proposal network to generate region proposals which are relevant to the query sketch. More specifically, we want to find the locations in the image represented by the grid which are similar to the query sketch. We want cross-modal attention to assign high score to the location in the image which are compatible with the sketch and low score to the locations in the image which are incompatible. Now we will talk about cross-modal attention in more detail. Given a target image and the query image, we use a CNN to generate feature map representations for the image and the sketch. In our experiments, we use resonant 50 to generate feature map representations. After that, we find a local feature vector which correspond to each location in the image feature maps. For the case of sketch queries, we use the global max pool operation to get a global feature vector for the sketch queries. After that, an attention matrix is generated, which indicates the spatial compatibility between each location on the target image and the sketch query. The compatibility score is computed by a scale inner product between the global sketch vector and each location of image feature vector. The attention matrix is multiplied with the image feature map to obtain attended image feature maps, which is then depth-wise concatenated with the original feature map. The concatenated feature maps are then projected to a low dimension space and is then passed through a region proposal network to generate region proposals which are relevant to the query sketch. Sketches have shown significant variability, but they often tend to capture complementary information on the object's shape, attribute, and appearance. The cat sketches in this example are very different from each other. Two of these sketches have only head of the cat, and one of these head sketches is missing the facial features like whiskers or the mouth. This complementarity can be combined to generate more holistic representation for the cat. In this work, we propose feature fusion and attention fusion to leverage this complementarity. In feature fusion, we take multiple global representations or different sketch queries and do the max operation at each of the indices of the sketch feature vectors to get the final representation, and then use it to generate the attention matrix. In attention fusion, we generate the attention matrices correspond to different sketch queries and take the average attention matrix as the final compatibility matrix between the target image and the multiple sketch queries. We compare the proposed model against the following baselines. Modified faster RCNN, which is already explained in the previous slides. And because of the vanilla RPN, It often fails to generate object proposals relevant to the sketch query, and therefore it is insufficient in this case. The other baseline is MatchNet, which is a recent work on image carried object localization. They utilize non-local features and squeeze and excitation in their region proposal network. However, it is insufficient in sketch carried object localization because non-local features suffer from domain gap between the natural image and the corresponding sketches. And because of the lack of alignment between sketch and image feature channels, squeeze and excitation is also not applicable. In our experiments, sketches from CakeDraw are used as queries, and the natural images from MS COCO and Pascal Walk are used as targets. 14 out of 56 common classes between CakeDraw and MS COCO are reserved as unseen categories. Similarly, for Pascal Walk, 3 out of 12 common categories are reserved as unseen. We performed experiments in two settings, disjoint train test and common train test. In the disjoint train test, only seen categories are used in training. In the common train test, both seen and unseen categories are used in training. Two separate pre-trained Resident 50 models are used as image and sketch encoders respectively. These encoders are pre-trained after removing unseen categories. For one-shot common train test, our model outperforms both the baselines in case of COCO dataset. However, in case of WOG dataset, the training data is too small to take advantage of the cross-modal attention. Also, the MatchNet baseline suffers because of the domain gap. In one-shot disjoint train test setting, our model shows significant improvement for unseen categories, and therefore suggesting the applicability of cross-modal attention in one-shot sketch-based image localization problem. For multi-query experiments, we use 5 sketch queries to evaluate feature fusion and attention fusion. In both disjoint train test and the common train test setting, the proposed fusion techniques show improvement over single query case. This indicates that the proposed feature fusion and attention fusion techniques are successful in judiciously combining complementary information present in multiple sketch queries. Now I will show some interesting quantitative results. Our model is successful in localizing multiple instances of objects in an image, for example, sheep in this case, the occluded objects, for example, the right van, unseen categories, for example, the fork in this case, and the small objects. To summarize, we propose a novel task of sketch carried object localization. Towards solving this problem, we propose query guided region proposal network, which utilizes the cross-modal attention, which is effective in generating region proposals that are relevant to the sketch query. It is a step towards open world object localization. In future, we want to incorporate object attribute and semantic information in the form of natural language in the sketch carried object localization framework. Thank you. For more details, check out our project page.